Jai Hind everyone. I Neeraj Sharma, Assistant Professor EC Department at Ajay Kumar Garg Engineering College, Ghaziabad. I am before you to present the video lecture for the complex topic series for the subject data communication and networks. So, which code is as per the AKTU curriculum, that is BEC 0762, BEC 062. So, the topic I have chosen for this video lecture, that is the connecting device. So, that means how the internetworking are connected between with each other in the TCP/IP model. So, I will try to give the little bit as just informative introduction as well as the detailed description here. So, for that point of view, so I have just now. So, what is this? Before moving ahead, just get the little bit idea regarding the what is this networking and internetworking devices. These two things will be important here. So, that internet is simply interconnection of main thing of the individual networks. That means if one LAN is placed here and another LAN placed, so the connection of these two, how it can be possible, or the devices onto this LANs, how it can be connected. So, this is an interconnection. So, to create a internet, we need a internetworking devices which is used to connect these two like LANs. So, that means that is number of LANs linking a number of LANs here. So, for that point of view, we are using this internetworking devices. So, just like internet, that is given by www, World Wide Web, or interconnection of these LANs, which are connected with each other and able to communicate with each other. So, how it can be possible? So, for that point of view, some specific devices are required. So, we have to study all these devices in this lecture. So, why interconnect? What is its need? Why we are going for this interconnect? So, first of all, the reason that is to separate or connect one corporate division with another. That means, if in a building, let's say the multiple blocks will be there. So, for the connection of one block to another block, for that point of view, we are required this interconnection. So, okay. Next one, to connect two LANs with different protocols that are going to use, which is using different protocol system. With that, another, that is to interconnect a LAN to the internet. To break, that means so that worldwide or some different places, the devices can be able to connect with the help of this internet, which is provided onto the LAN. But how this LAN connect to the internet? To break a LAN into segment to relieve the traffic congestion. So, that means if we want to manage the traffic on a particular section, we want to manage the particular traffic, so that it cannot be, we can say that traffic should not become heavy. So, the devices, the data can in the form of packet can be moved from sender to receiver easily. So, that means just to relieve this simply in a traffic. To provide also a security wall between the two different types of users. So, this is the need. So, where it is a requirement of this interconnection, internet connecting devices to interconnect these all the requirements like LAN to LAN, or different LANs, or LAN with internet, etc. So, for that point of view, the connecting device, what are these? So, there are two types, category can be classified here. One is networking device and the another is internetworking device. That means simply one network to one network connection. That means, or internetworking, that where we are providing with the help of internet, we are communicating from one device to the one LAN to the another LAN, let's say. Okay. So, for that point of view, we are using, so the network devices are the repeaters that can be used and bridge. These are to use as the networking device, and routers and the gateway, these two can be used as an internetworking device. So, what is this? How it can be worked? We will see now. So, in introductory part, we can see that many times it is necessary to connect a local area network to another local area network or wide area network. So, for that point of view, need to connect the interconnection will be required, which can be possible with the help of these previous mentioned devices. Simply a local area network to local area network are usually performed with the help of this bridge. So, this is bridge is one other one of the connecting device. Local area to wide area network. The LAN to WAN connection are performed with the help of these router, as you can see, which is where need of internet. So, the third device, that is the switch, can be used to interconnect the segment of local area network. If we are segmented the large LAN into the smaller section. So, the 5 categories of this connecting devices, which you can, this slide is itself is explaining more about this connection. So, that point of view, we are looking here that the TCP IP model, where the at sender side, let us say physical layer, data link layer, network layer, transport layer and application. Similarly, other and the receiver side, it will have here physical, data link, network, transport. So, how these two are connected with each other, how this layer of one section of connect with the other section, how it can be going to connect. So, for that point of view, it can be mentioned here. So, as you can see here, below this physical line, physical layer, this one part, the passive hub is used. After that, at physical level part, you can see that here the physical layer is connecting with the repeater or hub only. So, that means at physical layer connection is possible with the help of when we are connecting to the device at the physical layer level. So, repeater or active hub should be used here. If we are connecting this data link or physical with this data link or physical, so at that point of view, these two combination bridges should be used here. Bridges or two layer switch. So, this which can be mentioned here at the physical and the data link layer, bridge and two layer switch are used. After that, at network level we are connect, that means if we are connecting these three, physical, data and network itself. So, for that point of view, the router should be used here, router or 3 layer switch, which can be mentioned here, which can be used here. Okay. So, it means if we are connecting the network layer to the network layer of the different system, for that point of view, router will be used here. After that, at the level of this 5 layer, if we see along with this transport and application, these all, for that point of view, the gateway will be used for the connection of these two layers with the two different sections, which is included sender or receiver, we can. So, at all 5 layer can be connected with the help of this one section to another with the help of gateway. So, here the mention this repeater, hub, bridges, router and the gateway are the connecting device, which are used to connect the networking system. So, the first of all we will see what is this repeater. So, the repeater is a generator, not an amplifier. First of all, this is not an amplifier, but it is a regenerator. That means, if the signal can be destructed or attenuated, then it can be enhanced, regenerate again. So, it can be attain their original position or the original frame. So, a repeater installed on a link receive the signal before it becomes too weak or corrupted, regenerate the original bit pattern and put the refreshed copy back onto the link. So, a repeater operate only in the physical layer. A repeater connect the segment of LAN. Also, a repeater forward every frame. It has no filtering capability. So, the filter is a 2-port device that extend the LAN's physical length. So, simply if we are connecting the two length, these two lengths we have, the first one, for that connection we are using a section which will be named as a repeater. So, which you can see in this figure, where this first layer of this to first layer physical layer can be connected with the help of this device, which is a repeater, which presentation you can see here. So, here you can see that the segment 1, this is a segment 2, which we have discussed this part and this one. So, these segment 1 and segment 2 are connected with each other with the help of device, which is named as a repeater here. So, overall length of the networking side can be increased. So, the function of this repeater, if we say, so repeater is a regenerator, not an amplifier. So, when we are transmitting from right to left, so signal can be corrupted here, it will become weak. As you can see that Okay, but after passing through these signals with the repeater, then it will be now regenerated again. Similarly, when from left to right transmission, so in that point of view, the signal will be get degraded here, that means corrupted here, after that weak or become weak, so that now you can see that at the last stage it will become weak. So that when it will pass through the repeater, the signal will be now regenerated again. So this is a functioning of a repeater here. The next one, that is your hub, active hub, which we can use at the this physical layer level. So for that point of view, the active hub is basically a multi-port receiver repeater. Means in the previous section we can see that the repeater have the two ports. One is from one end, second one is another end. So that means there is a limitation that only the two lanes can be connected at a time, not more than two if possible. If scope we want, that means we have to connect the network with the same repeater, then what should be. So for that point of view, using repeater, that is your multi-port, more than two port which is having. So it is an active hub. It is active hub just simply a repeater, but multi-port repeater. So that now it is normally to create a connection between station in star topology like this. Hubs can also to use to create the multiple levels of hierarchy, removing the length limitation of 10⁻⁴ m. So in this section you can see this here, active hubs, this one hub which is connected to this star topology connection. So multi-ports, the 1 port, 2, 3, 4, 5. So that means number of lanes can be connected with the single repeater here. But it can be used at only and only the physical layer level. Next one is bridge. That means if we want to connect the data link layer and physical layer at the both side. So for that point of view, in spite of repeater, the bridge should be used here. So divide a large network into a smaller segment. First one, so it filters the traffic. It contains logic bridge table that allows them to keep the traffic for each segment separate, that is isolating and controlling the link flow, that is used to remove the congestion. So bridges have lookup table that contains physical address of every station connected to here. So that means it can be able to explain the which one particular device is connected at the time in the network, which can be this information along with this physical address that will be assigned into the bridge. So this is simply an interconnection of two identical local area network with the help of this bridge here. So this LAN 1, LAN 2 are connected, where these multiple devices are connected with each on this LAN. It is now connected to this LAN 2 with the help of device, that is the bridge here, which you can see here. So when a frame enters in a bridge, it checks the address of the destination and forward the new copy only to the segment to which the address which belongs it. So that means what? Simply when you can see that this one LAN 1, you can see here the A, B, C, D stations are connected here, and the LAN 2 where the E, F, G, H stations are connected, but these two are connected with each other with the help of device, that is your bridge here. So what bit it is having, because it having the physical address. So it is able to explain when the frame enters onto this, let's say A to E, G it wants to move here. So that what it should do, it will comes onto the bridge, then bridge will identify, because every station have the source and destination address. So it will reach the destination address where the packet wants to move or transfer. So now bridge will select that this one individual packet is related to this particular station. Now it will transfer as after the identification of this physical address onto the given in the destination with the help of in the destination section. So now it will transfer the packet directly to the respective station. So a bridge operate in both physical and data link layer, which we have discussed. So bridge have filtering capability, having a table used in filtering decision. A bridge can check, does not change the physical address in a frame here. So as you can see that, let's say port 1 and 2, which is having bridge table, accordingly address specification, it will have lookup table as well as the port. So that means you can see here in this section below, the LAN 1 and LAN 2 are connected with the help of this bridge, where this LAN 1 have two devices, with the addresses 141 and 142 at the last digit, and LAN 2 have the addresses of 112 and 113. So that means port 1, at the port 1, how much number of devices can be connected, which has been connected. So at port 1, this one device and this one. At port 1, which address is this one? At port 1 for this one. Similarly, port 2. So it will regenerate, it will create its own table, so that it can be used for the where the MAC addresses will be there, and where the data packet can be transferred, it can be easily transferred here. So the functioning of this bridge, if you see in the first one figure, a packet will move from A to D, where the two lanes are connected with each other with the help of this bridge. But A to D, it will move directly. But when the packet move from A to G here, so first of all, it will identify the object, the destination. Then LAN will inform that we don't have this particular packet packet for the particular station. Now it will transfer to the bridge, and now the bridge will check the destination address of the packet which comes out from the station A. Now it will identify that the LAN 2 have this G station, and now it will transfer the data onto this LAN 2, and this will transfer to the respective G station now. So this is a function of bridge simply. So what are the types? The types of these bridges are simple, multi-port, transparent, remote, source routing here. So these are the types of this what we can say of the bridges. Now what is a simple bridge? As you can see, so we will see now, it is a less expensive type. It links two segments only and lists the address of the all stations in the table, including each of them, which we already discussed. Here address must be entered manually. The table is modified when stations are added and removed here. So it can be modified process can be possible here. So multi-port bridge, it is used to connect more than two lanes. So the bridge has three tables here. So here address must be entered manually. So LAN 1, LAN 2 and LAN 3, these are connected with each other. So this is simply a multi-port bridge here. Transparent bridge. A transparent or learning bridge build its table of station on its own. That means automatically it will create as per the requirement. So the table is empty when it is installed. It build its table when it is encounter the packet for transmission. It uses the source address for building the table rather than the destination address. So the bridge is able to identify that how much stations are connected with this bridge. So it identifies the changes and update the table when the system moved off from one station to another. So these transparent bridge are used here, in which the stations are completely unaware of the bridge existence. So it is named as a transparent bridge. So three criteria of transparent bridge are: frame must forward from one station to another. The forwarding table is automatically made by learning frame. Movement in the network, loops in the system must be prevented. So what is these? Also now we will see. So bridges are normally installed redundantly, that is two lanes may be connected by more than one bridge. In this case, that means the single lane can be connected with the bridge 1, 2, 3, XYZ. So but in this case, they may create a loop here. So what is it? Now we will see. So in that case, so packet may go round and round, but it can be avoided. But that means they are not able to identify the actually the destination is how it can be packet will be moved. So this issue can be resolved by the help of spanning tree algorithm or source routing algorithm. So this is a transparent bridge. You can see here this bridge have the three port 1, 2 and 3. LAN 1 have connection stations connected A and B, at 3 E and F, and at 2 the bridges have the C and D here. So in the first case, when original position initially bridge is not aware that how much stations are connected, but when the transmission is started, that means the movement of data packet will start, then it will create its source its lookup table. So originally this table is blank, that is address and port respective. Then now after that after A sends a frame to D here, that means A to D here, this one. So when after what will happen, then the bridge will identify that the LAN will identify that we don't have the system D on this location, so that it will pass to this bridge 1 at with the help of port 1. So that means A is connected at the port 1. After that, now after E sends a frame to A, then this one E sending data to E here. So what it will happen? It will identify that on its LAN A is not available. Then it will move to the, that means it is available to some another LAN. So in that case, what it will do? It will transfer the data onto the bridge which is connected to the port number 3. So E connected to port 3. Then after that, B sends to a frame to C. B will sending to this data to C here. So identify itself, not able to identify, then it will transfer the bridge with the port 1 and this will be now updated. So lookup table can be created automatically, which is having the source address and port number at the particular where it is all connected. The loop problem created when the two lanes are connected with the more than one bridges. So bridges are redundantly, that is two lanes may be connected by more than one bridge. In this case, may create a loop. So packet may go round and round. It can be by the algorithm like source routing or spanning tree, that spanning tree algorithm. So for that point of view, when A wants to send the data to D, so here you can see that, so it will move to D along with this bridge 1 as well as bridge 2 here. So that what will happen here, both bridges forward the frame. This bridge identify that the D is connected onto LAN 2, another bridge 2 also. So what will happen here, then A to D or A to D, two copies of the frame on LAN 2. After that, a bit now the two information, now it is going to confuse. So what it will do, it will revert back to that. Again it will be comes back. So what is going on here, it is not able to identify the lane on these two bridges, not able to identify the exact position. So in that form, a loop will be created here. It will moving rather than to moving from between LAN 1 and LAN 2. So not able to get the actual identification. This is a loop problem in the learning bridge here. Learning bridge, that means transparent bridge. Next one is remote bridge. A remote bridge is capable of passing a data from one local area network to another when two lanes are separated by a long distance. This one. For that point of view, remote bridge are now used here. A remote bridge takes the frame before it leaves the first lane and encapsulates the WAN headers and trailers here. When the packet arrives at destination remote bridge, that bridge removes the WAN header and trailer, leaving the original frame here. So this one regarding the bridges. Now switches. Switches is simply a combination of hub and bridge here. Both are using simultaneously. So it can connect two or more workstations, but like a bridge, it observes the traffic flow and learn here. So when a frame arrives at a switch, the switch examines the destination and forward the frame out the one necessary connection. So here the workstation that connect to a switch are on a switch segment here. So that can be two-layer switch system you can use here. So you can see on these frames here, switch can be used. A layer 2 switch is an N port. This one 1, 2, 3, 4, 5, as you can switch in the in the domain case, in the duplex mode, full duplex mode, in Ethernet switch on or LAN switch, switched Ethernet, full duplex Ethernet. These are all the examples of this two-layer switch here. The two-layer and three-layer switch, if we will see, so the two-layer switch bridge with many port, that means bridge with many port becomes the switch here. Two-layer filtering based on the MAC address of frame is received. Build switching table by learning host address from the source address of incoming packet. The next one, that is your router here. So the three-layer device that routes packet based on their logical address work at the network layer. Builds routing table by neighboring routes using the routing protocol. Unknown IP packets are discarded. Broadcast frame can be discarded here. So the three-layer switch is a router, but a faster and more sophisticated here. So the last one that can be here, which can be operated, if we can see that in previous initially when of the diagram. So the gateway can be used to make the interconnection at the upper layer of the two devices. That means from device to device connection with the help of internet. So it can be the problem can be resolved. This connection can be available with the help of this gateway. So a gateway is a protocol converter here. So it accepts a packet format for one protocol and converts converts it into a packet format to another protocol here, this one. So it can have having a protocol conversion capability here. So this is simply a connection of this gateway diagram. You can see here one network, this one, this is another network, device to device connection. So you can, this SNA can be connected with this netware with the help of this gateway, where the protocol used, which can be converted this SNA to the network here. So this SNA network is of, let's say, IBM. It is of Novell, that can be connected with each other with the help of this gateway here. So virtual LANs. So a LAN configuration by software, not by physically wiring. So VLANs create broadcast domain. So a VLAN is a logical grouping of devices within a LAN regardless of their physical location. So the purpose is to segment a network for better management, security and performance, reduce broadcast traffic, enhance security. These are its benefit. Implementation can be possible with the help of switches using IEEE 802.1 1Q tagging here. So the example are VLAN 10 for HR, VLAN 20 for finance device communication only within their VLAN. So as you can see here, at a station, let's say we can just like an example you can see here. Let's say if any building has the 3 floors and all have the 50 employees there, and the leader of that company having a project, that means every floor have 50 employees. They are using some specific task. 50 at floor 1, floor 2, floor 3, they are using their specific task. But one task when comes up from the project will comes out that needs some specified employees to work onto that particular project, but they have connected selected from the different floors. Let's say 10 have selected from B, second 10 5 from 1 and 5 from 1, let's say 1, 5 from 2 and 10 from 3. So now they are using placed onto the different layer, the different floor, but working together with the working together for the same project without the interruption with the another one. So in that case, a virtual network has been created to connect all these 3 at which is asides and sitting at the different floors on the particular building. So in that way, the connection of these special selected candidate station, like station on the different LAN, which used to perform the specific task. So for that point of view, the LAN connection will be created, which is named as a virtual LAN here, which you can see here. The VLAN have the 4 segment, VLAN 2 and VLAN 3 here. So some paths for that point of view, they can be selected for individual tasks. Let's say 1 from this, 2 from this and 1 from this here. And the combinedly merger or combination without interrupting to another, that one is possible with the help of this virtual LAN here. So this is a concept of virtual LAN here. So this is now from my side regarding this connecting devices. So thank you and Jai.